he has joined. Dr. Himanshu. Yeah, yes, sir. Yeah. Let me make you co-host, sir. Make co-host. Yeah. Yes, sir. Sir, you can now unmute yourself and you can share your screen.
Okay, thank you, Dr. Manjit.
Thank you, sir.
Good afternoon, everyone, and welcome to the second session. So here, as discussed earlier, we'll be discussing about one case study and through a particular research methodology regarding to the sustainable manufacturing. So someone is saying no voice.
For me, it's clear, sir.
Maybe at their end, the problem is at their end. So
now it's okay, sir. Yeah.
I will start with this particular topic or case study that we had conducted recently. So it is basically integrating all the major practices like Industry 4.0, cleaner production, and circular economies. So these three practices. So through that, we have prepared an integrated framework for evaluating ethical and sustainable business performance of manufacturing organization. So that was a case study that we had conducted, and particularly we have used certain research methodology for that. So I'll be discussing the case methodology through that only. And one portion I will be discussing here is regarding the framework that we have developed and how we can see which components are important in that framework and how we can evaluate that. So starting with this one regarding the introduction to our particular case study that we had conducted, is related to, as mentioned in the topic, it is related to the sustainable business performance of the organizations. And we know that organizations nowadays are facing pressure because of the changing manufacturing scenario and their shift from traditional to the sustainable practices. So sustainable cleaner production and Industry 4.0 standards are required. These practices are required for this manufacturing organization to be more sustainable. And there are certain concepts associated with Industry 4.0 also, like we discussed in earlier session also, that organizations are adopting practices such as cloud manufacturing, additive manufacturing, disruptive technologies, big data analytics, Internet of Things, artificial intelligence, then cyber physical systems. So these practices are now being adopted by the organization more and more in order to. Yes. I would request everyone to keep their mics muted, and if you have any query, you can just type down or ask towards the end. So now these digital technologies or digitization technologies, along with circularity principles, are necessary for sustainable manufacture, and even this digitization technologies help overcome the certain barriers to circular economy or circularity also. And this digitization technologies, they are acting as an enabler for many organizations to adopt to identify what are the indicators of ethical and sustainable business manufacturing. Considering these three aspects in mind, that we are saying that circular economy, Industry 4.1, cleaner production. And first thing is to identify these things and develop a framework. And then our objective is to rank and prioritize those indicators of ethical, sustainable business manufacturing or sustainable business. And apart from that, we also ranked certain manufacturing organization on the basis of these indicators, but we'll be focusing more on developing the framework and ranking here. For the purpose of conducting this case study, we have used a multi-criteria decision-making approach or multi-criteria decision-making tool for ranking that, and basically the indicators have been identified through literature review and various round of discussions with experts. Now coming to first of all, the ethical and sustainable business performance. So as we have been discussing, basically the concept of sustainability, it includes three things, three pillars: economic, environmental, and social aspects of manufacturing and supply chain. So nowadays, management is realizing the importance of ethical and sustainable businesses, and they are trying to adhere to various environmental standards that are set, and the various regulations that are set by the government time to time. They know the importance of collaboration with the suppliers, that with collaborating with suppliers or developing their suppliers also is essential if you want to achieve the goal of sustainable development across the supply chain. The importance of life cycle assessments of products, of material is being realized more and more, and use of cleaner production technologies, new technologies, effective use of byproducts, effective use of recycling techniques is also being realized more and more. So, but there are certain issues that organizations are facing, especially in the developing countries, that are making them difficult to adopt all these technologies or work towards all the three pillars. There are certain internal barriers, organizational issues. So our sustainability related practices, or this latest technologies practices like Industry 4.0, big data, and circular economy practices, they can help overcome certain barriers also, and they can assist for smoother transition from our traditional to the sustainable businesses. And we have to focus not only on sustainability, we have to focus on social sustainability also, and ethical business also, where we are meeting the latest standards set by government and regulatory bodies. So for our study, we have considered three prime indicators for sustainable business performance, or three prime enablers, we can say. First, we have indicated in Industry 4.0, so which we know that Industry 4.0 is referring to the fourth industrial revolution, as I said in the previous session also, where there we can say that where we are using latest technologies like sensors, radio frequency identification tags, other technologies like Internet of Things, big data analytics, artificial intelligence, 3D printing. All these technologies, when they are systematically arranged and combined together to form a cyber physical system, that is, all the physical systems, arrangement, factories are attached to our online system, cyber system, and we have access to our factories sitting anywhere in the world. So that is Industry 4.0 concept, and it basically helps us in customizing the production as much as possible, and also mainly since we are saying that now we have all the real-time information of data with us, we are able to do vertical and horizontal integration of the production systems and do basically flexible manufacturing also. Here we can produce product as per the customer requirements also. And we have seen, although as I was discussing, there are not means our organizations are not fully moved towards Industry 4.0, but still we are trying, many organizations are trying to adopt certain concepts, like we have seen the concepts of our smart homes that are there. So we have technologies like, before even entering our home, we can switch on our heating system, we can switch on our air conditioning system, so that by the time we reach home, the temperature is properly set. We have smart fans where we can control it through mobiles. So that concepts are being coming. We have seen companies, organizations who are working towards smart medical equipments also. There are companies where they have produced smart clothing system where by wearing your t-shirts or wearing your shirt, you can also monitor your like heartbeat, your blood pressure, these sort of things are there. Now, people are working towards smart vehicles also, automated vehicles also, and more and more of these technologies are being adopted in Indian organizations also. So that help us in some way achieving our target of sustainable manufacturing. Another is the sustainable and cleaner production technologies. So by sustainable and cleaner production technologies means that we are using technologies where we are ensuring that we are using as less as possible our various resources. We are conserving resources. We are producing things that require less resources, that emit lesser waste, lesser hazardous materials in the environment, and these become critical for achieving our sustainable business development goal. People again are using many sustainable and cleaner production technologies in their organizations, although again this is not being fully adopted right now. Like many organizations that are there, they are when sending their products outside to the organization, they are asking them to resend us back the packaging material that they have sent for. After packaging the product, they have sent the material. So they are asking those organizations that once you receive the material, please send back the packaging material. Although this might look a very small thing, but it still adds to the somewhat to the sustainability initiatives that organizations are taking. Organizations are now more aware about the lesser energy consumptions. They are asking their employees to use less and less of energy, be it like electricity. They are asking them to switch off the electricity, switch off the appliances whenever it is not required. This is more prominent in service sector we are seeing, but in manufacturing sector also these practices are being adopted wherever possible. In service sector, we are seeing the people, especially after COVID, switching to working from home, or they have shortened their means, they have reduced their office space by letting out the space to someone else, and because now they require less space because more and more people are working from home. So they are able to save a lot of money on those resources, those energies consumption. People are focusing in production on lesser wastage of material, because now more material will that is wasted means that we have less material in future for the production. So they are focusing on ways to reduce material wastage, and one way is, like we have discussed, is the rapid prototyping or 3D printing techniques, where we have almost zero waste. But those who are following traditional methods, they are also thinking of ways to reduce the material wastage. So that is also one essential component. And third, that we have taken for the purpose of case study is the circular economy. And this circular economy concept we have discussed in detail, where we are saying that we are following the 6R principle: repair, reuse, remanufacture, recycle, refurbish, wherever it is possible. So our goal is that no material should get waste once the materials enters into the system, or once we have extracted any resource. So we utilize it to the fullest as much as possible. Now, these are the certain indicators, certain components that we have taken, and we want to develop a framework by further seeing under each component what can be the possible indicators for our organization. So we, under case analysis, we had the objective of proposing a framework by integrating all these concepts of Industry 4.0, sustainable consumption, production, and circular economy. We used a combination of quantitative and qualitative techniques. For the purpose of case study, 10 experts were involved, and multi-criteria decision-making technique was used. We ensured that experts have had at least 10 years of experience in the relevant field, so that we can come up with a more robust framework. Multiple round of discussions were held. First round of discussion was held after reviewing after framing the initial framework through literature review, that what can be the possible indicators under these three categories. And then the discussion with experts were held, where they were asked to indicate whether they think these indicators that we had identified through the literature review, they are related to our particular case study or not. And once that was finalized, the most relevant indicators were finalized, then the MCDM technique, that is best worst method, was used to prioritize the identified practices. And as I mentioned, 10 experts were used, having at least 10 years of experience, and you can see the profile of the experts. We had experts from different areas to ensure that we get proper opinion about different areas related to the manufacturing sector. And we also involved people from the academia, because academicians are now more working towards these things, although in application phase might not be there, but academicians are researching on this thing to ensure that the framework is more robust. Now, coming to the framework development, as I said, we had three categories. We classified it into three categories of indicators. First one was Industry 4.0. So under Industry 4.0, we thought, or we researched, that what can be the possible indicators or practices under Industry 4.0. So these five were identified through literature review and through discussion with experts. One is the Internet of Things, other is big data technologies, then third is smart factory and cloud manufacturing, fourth is additive manufacturing and 3D printing technologies, and fifth is robotic system. So this is one part of our framework development. Second important indicator that we used was sustainable consumption and production, and again we researched about what can be the possible indicators. So 6 indicators were finalized after literature review and discussion with experts. That top management commitment towards these practices, energy and material use, natural and clean environment related technologies, packaging and design, competency and skill set of workforce related to these green technologies, and supply chain collaboration indicators, because it is important that if we have to achieve sustainability, we develop our suppliers also in that line, and we ensure that our suppliers are also working towards these concepts only. And third one was related to the circular economy indicators that are there. So circular economy indicators also were studied, and means there are certain indicators under circular economy. So that slide somehow got missed. So I'll just let you know what we had thought in circular economy indicators, or what were the various indicators under circular economy. So under circular economy, we again thought of or reviewed certain literatures and other studies. And under circular economy, we identify 6 prime practices. Maybe first one was related to the recycle and reuse technologies that we are having. Another is that an important indicator was that end of life determination, that we are able to, or we have technologies to determine when the product useful life will be over. Then another important indicator that we were discussing in first session was the traceability. So traceability related technology or supply chain traceability, whether we have or not, and certain reduction in supply chain related risk. Other thing, the other factors that were there in this circular economy were that investments that we are making under this recovery and long-term scenarios, recovery of the materials, more recovery of the waste, and other lastly, one factor was related to the legal compliances, whether we are our organization is complying to the legal things that standards that are set or not. So these were the indicators that were finalized. Now the target is that among these indicators, first thing is that we wanted to see which one is the most important, which one are the most important for the case organizations that we have taken. So a basic framework was developed, and then we have to see which one is the most important. Now, as you can see, there are multiple indicators in our study. So we can see that we have taken three main categories here: Industry 4.0, sustainable consumption, production, and circular economy. Under first one, there were 5, and under next two there were 6. So total we have 17 indicators, sub-indicators of sustainable and ethical business organizations, and 3 main indicators. Among these 3 and 17, we have to choose which one are more important for us. So this is a case where we have multiple criteria and we have to make a decision regarding to this, that which one is more important for our organization. And once we have identified more important, then we can see whether which among the group of organizations are performing well on these indicators. So this is a particular case of multi-criteria decision-making problems, and for that we applied MCDM technique. Now, to understand MCDM, it is applied where we have a multiple set of criteria and we have to make a decision. Like as mentioned here in this example, let us say that we have to select a car. We want to buy a car and we have a multiple options available with us among the various models that are available with us, and we have to select which one to buy. Now, for one person, one parameter might be important. Like for me, the price is important, that I want a basic set of features and I want a car that is less costlier for me. For other person, the quality might be more important. For the third person, the style might be more important. The car should look stylish. I don't have any problem with the price, and all features also are not of much importance. Basic features should be there. And for another person, safety is of most prime importance. Now, when we are saying that there are multiple criteria and multiple options to choose from, so it is quite possible that this selection becomes complex, and this situation becomes more and more complex when we have more criteria. Like in this example, we are saying that we are having 5 criteria, and on the basis of that we have to select. So 5 different criteria may be different for everyone. Here we have to choose among these 5 which one is the best. So this is a scenario where we have multiple criteria and we have to make a decision based on these criteria. So first of all, if we want to make a decision, we need to prioritize which one is the most important criteria among these, so that we can now make a well-informed decision about it. Unless and until we know what is our priority, which criteria is most important for us, we do not have, means we won't be able to make a proper decision. So if we think like we are a family here, a family wants to buy a car, there are 5 different people in the family. Each person is saying this one is most important for me, this one is second, this one is third. Other person has other opinion, other has other. So all 5 have different sort of opinion. Now we have to optimize which criteria is better and then go for buying a car, because ultimately all 5 have to use that car. So now this becomes a complex problem. Multiple criteria, multiple people involved, and you have to select one among that. Now you will prioritize, the family will prioritize which among these criteria is most optimal for all of us, and then we will go for buying a car. So similar is the scenario in the manufacturing sector or other sectors here, that if we want to, let's say, select a supplier, we have multiple suppliers available with us, but we have listed down certain criteria that for us lead time is important, for us the quality of the product is important, for us the communication is important, for us the raw material price is important. So we have multiple criteria. Now each department in the organization might have those their own set of priority for the criteria. Now they have to select one supplier amongst the available. So first of all, they need to prioritize that which criteria is most important for us. All are important, but which one is most important for us, so that we can go for the supplier selection, best select supplier for our organization. So our framework that we have developed, again, we are saying that we are having three main category things, that Industry 4.0, sustainable consumption and production, and circular economy. And under that, 17 are there. Now we have different people. We want to see which one is the most important for sustainable business manufacturing, which criteria is most important for sustainable business manufacturing, so that we as an organization now work on these criteria first, these parameters, indicators first, so that we reach closer to our sustainability goals. Others also need to be worked on, but first, which are the few which, if we take up, that we will be much closer to achieving our sustainability goals. So the framework identified through literature and expert discussion came up with 3 main criteria and 17 sub criteria. Now we have to select the best. So this is a classic case of multiple criteria decision making. So that's why we have used MCDM technique. Under MCDM technique, we have now variety of techniques available. We used among them best worst method. So any MCDM technique generally has this sort of structure where we require data in the matrix form, where C1, C2, Cn is representing a set of our criteria, and A1, A2, and so on are representing a set of alternatives. So for car example, 5 criteria are there, and we had 3 alternatives, let's say. And we have to give the score, like I mentioned, of with if we are directly saying of alternative with criteria, so score of alternative with respect to certain criteria. It is possible that we are not considering alternative in the first phase, like we will be doing in our case. Then there will be only criteria, comparison of one criteria with the other criteria. So that is our case. Now coming up with this best worst method that we have used. So best worst method is a part of MCDM methods only. It was developed by Professor Jafar Rizai of Delft University, Netherlands in the year 2015. And since then there have been many evolutions of this methodology. And here the basic purpose is same, but again some additions and all. So we have used the version that was evolved in 2016, our study. Now here we have certain set of criteria. We need decision makers and their preference rating of one criteria over other. Since we are doing rating or we are doing comparison, we require a scale. So we use a Likert scale here, where the lower number, let's say we are using a 1 to 9 Likert scale. So lower number is representing very low importance of criteria 1 over other, criteria I over j, and 9 is representing very high importance of criteria I over j. And we can, it is not necessary that we always use 1 to 9 scale. We can use scale like 0.1 to 1, 1 to 100, according that is up to ours. But in general, 1 to 9 scale is used in most of the studies. Steps of best worst method. So we are not going in detail about these steps. Basically, this best first method uses linear programming as its base for bringing out the optimized result, where our goal is to get the optimized criteria weights. So main thing in understands that we need to understand here in this case is, generally when we are talking about any other MCDM technique, we are saying that we require a pairwise comparison matrix. And by pairwise comparison matrix, we mean that let's say we have a certain criteria C1, C2, and C3. We have 3 criteria. So we need pairwise comparison. We need to perform pairwise comparison here. So matrix will look like this. A pairwise comparison matrix will look like this. Now we need to have a pairwise comparison here. So when we are saying the importance rating of one over other, one factor over other, we need to have a pairwise comparison. First of all, if we see C1 to C1, so obviously it will be having same importance. Similarly, C2 to C2 and C3 to C3, they will be having same importance rating. Now we can use a scale of 1 to 9 here. If we are using any other technique, so there we will give pairwise comparison. Now we will compare what is the score of C1 to C2. What is the importance of C1 over C2? Let's say we think it is more important, so we put it 7. What is the importance of C1 to C3? We, with our experience, we think that it is moderately important. Let's say it is, we gave it score 3. Similarly for other score and so on. So all these scores we need to give, and these scores, for obtaining these scores, we involve those experts. That's why in our study we involved 10 experts, because so that to get different opinion from different experts, and they are considered experts because they have been working in that sector for more than 10 years, and they have the knowledge of which criteria is more important than the other one. And different opinion of different experts were sought, and then this weights were calculated, and then that was done. So this is a normal multi-criteria decision making technique. Now, coming to the best worst, this is any other technique if we use. So best worst technique basically has certain advantage over other normal multi-criteria decisions making techniques that we use. Here we are focusing on 2 important vectors only. We are not following or forming a full matrix like this one. Our focus is on 2 vectors. That is, one is pairwise comparison between criteria B over other criteria, and this will be the one vector where where B is representing the best criteria that we have identified, and AB1 is the rating of best criteria with respect to one criteria or over criteria number 1. AB2 is representing the rating of best criteria over criteria number 2, and so on. And second comparison matrix is other with the worst criteria. This comparison we have to do where AW is representing our worst criteria that we have identified, or the least important among the list that we have identified, and A1W is representing the rating of criteria 1 with respect to our over worst criteria. A2W is representing the rating of criteria 2 over W. So we do not require this full pairwise comparison matrix. We require pairwise comparison matrix in terms of these 2 vectors only. So that is the major advantage of using best worst method, that with lesser data we are able to achieve more results. So we will convert all these things into linear programming model. I am not going in detail about this linear programming model because we are not going to solve manually the linear programming model. We have a Excel package for that. Through that we can do that. So we are not going into that details of how to solve it. Now, to understand how the ratings are done in best worst, in any MCDM method generally that we are using for ranking, So what we do is that we are giving rating between certain parameters, 1 or 2 and so on, or this criteria. But when we are giving rating, we have to ensure that the ratings are consistent. That for that we calculate the consistency ratio. So to understand it more, let's say I am saying that again, I have these 3 criteria, C1, C2 and C3. If I am saying C1 is more important than C2 and I am saying C2 is more important than C3. So by logic, it should be true that C1 is also more important than C3, because I am saying C1 is important to C2, C2 is important to C3. So by logic, C1 should also be important to C3. So we have to ensure, or the decision maker have to ensure that when he is giving rating like this, he should ensure that this sort of consistency is maintained. And in best first method, we can understand the rating in such a way that if we try to see it like a tree, these three criteria we try to see as a 3 trees. So here the first thing that we do in best first method is we need to clearly categorize which one among the available criteria is best, that is the most important for us, and which one is the worst, that is the least important for us. So this looks simpler when we have only 3 criteria like mentioned here, but generally we have more criteria. So they are determining this, and then determining the pairwise comparison becomes a bit difficult. So we have to see it like this. So let's say this one is C1 is the tallest, it is the best, and C3 is the shortest, it is the worst or least important. Now we have to see, when we are giving the rating, we have to see it as a distance, that the distance between the best and worst should be maximum. So we are saying on the one hand we have the best, most important criteria, on the other hand we have the worst, that is the least important criteria. So this we have to consider it in terms of distance. The distance between best and worst is maximum. And when I am saying maximum, since we are using a scale of 1 to 9, it should be near this value. So in this particular, let's say we have given it 8. Now there is an intermediary tree also, that is C2. Now we have to see the closeness of C2 with the best or worst. So by experience we know here, or by seeing here we know that this is C2 is closer to the best one. So if it is closer, the rating should be less, like mentioned here. And now if it is the distance between this and this is 8, we have given it 8, we are saying it is 2 times, it is 8 times far, we are saying it is the intermediate C2 is 2 times far. So then by logic it should be intermediate should be 4 times far from the shortest tree. So this will ensure the consistency, and that is what this formula is saying also. ABJ is representing the best with J criteria, AJW is representing the J rating of J with the worst criteria. So we have considered this as J. So this rating ABJ is given as 2. Distance between, let's say, best and the J, into AJW, rating of J with respect to W worst. It is given 4. So it should be 8 equal to 8 for a fully consistent comparison. And that is what we have given. The rating between best and worst is 8. So this gives the fully consistent result. But it is not necessary that we always give fully consistent result, because that is not possible also while we are giving pairwise comparison ratings for a lot of criteria. So we have to try to be as closer as possible in this scenario, because perfect consistency is not always achievable. And for that we have a leverage also, that we need to ensure that this consistency ratio, the value whatever we are getting, should be less than or equal to 10%. So this is the leverage we have, because full consistency is not possible, but we have to ensure that it is close, as much as close as possible. And we have this leverage more when here the number of criteria increases. Lesser the criteria, that chances of inconsistency becomes more. So more criteria, the number of criteria increases, we have that leverage there. So this is what is mentioned here. Consistency ratio should be closer to the 0, but it should be less than 10%. So this was about the some basic introduction about the methodology. Now coming to the how we have to calculate it, how we have to get data and how we have to calculate it. So here I am showing you the raw data here. So you will see here that in this case we have taken the data for this particular case study that we had. We had 10 experts. Data from each expert is mentioned here. And then for each of that, after taking data for 10 experts and calculating weights here, we take the average. So how data is to be taken? So we'll consider one case here or one expert here. So you see that first of all, we are talking about the main category here. We have 3 main categories, and under each category we had further certain variables. We are talking about the main category first of all, and with main category we ask all the 10 experts to give their ratings. First step is that under each one we identify which one is the best. So expert 1 was asked to identify which one is best. So he said, so SCP, that is sustainable consumption production, is best for, according to my opinion. Second thing is that we asked them among these 3 which one is the worst. So he said that industry 4.0 is the worst, means not in that sense, it means SCP is the most important and industry 4.0 is the least important among these 3 criteria that are available for discussion. Now next step is that we do the pairwise rating here. So as I said, we require 2 vectors. One is that we talk about best to others, and other is others to worst. So once we have identified the best criteria, we have to give the rating from best to others. So first of all, we see the best to best. Best to best will be same because both are same criteria. Then we should go for rating of best to worst. So since it is the worst or least important, as I said, we have to consider it as a distance. So it is, we can consider it as at a larger distance. So, yes. So we have to consider it at a larger distance, that is sustainable consumption and industry 4.0 are at a largest distance. That is 8. We could have given it 9 also. Then comes the rating of best to other, that is the third criteria that is left, and expert said that it is 4 times that away, or means the distance which is in between somewhere. So second vector that we require in this case is, after identify which one is the worst, we have identified the industry 4.0 is the least important. So then others to industry 4.0, others to worst. So industry 4.0 to industry 4.01, then sustainable consumption and production to industry 4.08, because there also we have seen that it is 8 sustainable consumption production, and to industry 4.0 was 8. Now second is circular economy to industry 4.0. So the expert has given it a rating of 3. Our prime target is that we get the weights of these 3 variables, and weights will determine the importance rating. Accordingly, we can rank, and this psi star value is representing the consistency ratio, and as I said, it should be less than 10%. So that is our target here. Now these ratings are obtained. How these weights will be obtained, that we will see here. So for that, for solving that, we have already with us a Excel solver that is available or developed by Professor Rezai, that is available with us. So I will just move to that solver. So you can type for BWM solver in Google. It will take you to a website, bestfirstmethod.com. There you can download the solver, this Excel solver, and there are other resources also to help you understand more about this methodology. In this solver, all the instructions of how to proceed is also given. So we can go through those instructions also. Then you will see there are tabs mentioning C equal to 3, C equal to 4, 5, 6, 7, 8, and 9. This C is representing basically the number of criteria that it can handle. So this particular solver, you can see, has the ability to handle from 3 criteria up to 9 criteria at a time. So in our case that we have taken particularly now, we have this problem where we are dealing with 3 criteria. So we can type the name of criteria here. So we had 3 criteria, that is IDY, SCP, and CY. So we can change the name here. IDY. Second. So we have changed now the name. Now here we have an option, automatically drop down will come to select the best. So expert one has said that SCP is best, and he said that IDY was that is least important. So you'll see these things have changed automatically here. Best is selected, worst is selected, and these things have changed. Now you can delete this previous one. Now the rating, we have to give rating as per the expert. So expert has given this rating SCP to IDY 8, SCP to SCP will be 1, and this is given 4. Similarly, IDY to IDY will be 1, SCP to this will be 8, this was given 3. So we will enter the data here. Then under this data tab, we have an option of solver. Once you will click the solver, this linear programming problem will be automatically formulated. So it has constraint, it has objective function. Those who are aware with the linear programming, they will know about it. Even though those people who are not aware about linear programming, they do not need to worry. They will just, our purpose is just to obtain the results here, obtain the criteria weights, so that we can see which one is the most important. Everything will be automatically taken into the solver. We need to just click on solve. So you will see that it has calculated the weights like we have seen in the previous in our Excel sheet. So it has given a weightage of 0.083 to IDY, that was the least important. Then 0.72 to SCP, that was the most important. 0.194 to the CY, and psi star value is also 0.0833, 0.055. So this is indicating the results are consistent. So this way, we, as I have shown here, this way we can obtain the weightage of each of the expert. Now going back to my sheet where I have kept the data here, so you will see this one we have got for the expert one. Similarly, for all the 10 experts, we have calculated the weights. So you can see the different weights for expert 1, 2, 3, and so on to all the experts. Then finally, we have taken the average score of all the 10 experts and find out the average weights here. This is helping us to calculate the final ranking among these 3 which one is best. We can see that in the circular economy practices are the most important for the company's perspective for sustainable manufacturing or sustainable businesses, followed by sustainable consumption and production, and then industry 4.0. This is about the main category only. Similarly, then under next step, we have to move to the second category, that is means first main category, that is industry 4.0. And we have seen in literature or in our framework that industry 4.0 further has 5 subcategories that we identified in industry 4.0. And we need to then do the ranking for that also. And our overall goal is to rank all the 17 subcategories. So what we have to do is, under each main category, we have certain subcategories. First of all, we will find the weights of each of the subcategory criteria or sub criteria under main categories. So you will see, like here we have 5. Again, we went to all the 10 experts and asked them to give a pairwise comparison rating after identifying the best and the worst. And then we did the analysis. So again, let's see if we move to with this 5 one in the solver. So IDY2 is the best, IDY5 is the worst in this case. Again, we are moving to the solver. So here we have 5 components here. We'll move to this tab. So here, first of all, we need to change the criteria name. Now we have to give the ratings as given by the expert. IDY2 was the best, IDY5 was the worst. So IDY2 was best, IDY5 is the worst. Now again, the same process, we have to give the rating here from best to other. IDY2 is represented best, so best to others, the rating we have to give. So again, we will see the what are the rating 3, 1, 5, 6, 9. These were the ratings. Since you can see best to best is 1, Y5 is the worst, so it is the at the maximum distance. Since we are using a 1 to 9 scale, it is towards the maximum possible distance, that is 9. It is given. Second, we have to go for others to worst. Again, rating has been given. We'll just copy the rating from there. 49321. Then, like the previous one, we'll go to solver. The problem is automatically formulated here. In this case, we will click the solve. It will solve it. So it has given the weights and the consistency ratio value. One thing while we have to ensure while calculating the weights is whatever the number of criteria are there, whether we are going with 3 criteria at a time, whether we are going for 5, whether we are going with 9 criteria at a time. The sum of these weights of all the criteria should always be equal to 1. It should not be less than 1 or not cannot be more than 1. If it is coming like that, that means there are some errors in our calculation. So always we have to ensure that the sum is 1 here. Now finally, our purpose is to see the overall ranking. So like we have calculated the average here for the main category, considering by calculating for all 10 experts separately and taking the average. Similarly, for industry 4.0, this average weights is calculated. Then we move to SCP, sustainable consumption and production. Again, the rating is taken and average for SCP is calculated here. And last one was circular economy. Again, there were certain factors, 7 factors, sorry, and there again ratings for each is calculated, or the weights, average weights are calculated for each one. Now the purpose is in this framework is to rank which one is best among all these 17 or 18 criteria. So for doing that, what we'll be doing, we'll be using the main category weights and then multiplying that main category weights with the particular subcategory weights that we have obtained so far. So final result will look like this. So here you will see what I have done. I've taken the main category average weights of 10 experts. So these were the main category weights. I have copied that main category weights under this each of the subcategory. So each subcategory weights are available with us because we have calculated that. For each subcategory, we have calculated the weights here. Now we want to see among these 18 criteria, which one is the most important for the sustainability perspective. So for that, what we have done is we have taken main category weights multiplied with the subcategory weights. So main category weight of that particular category into subcategory weight of that particular category. So that will give us the global weight. So here you will see this is this into this main category of this one. This similarly, you will see here this one is this. Once we have global weights, now again we have to check here, since there are no 18 sub criteria or 18 criteria in our framework now. Finally, we have to, and we have calculated the weights. We have to see that the sum of these global weights is also equal to 1. So you will see here total 18 criteria, sum of these are 1. Now we will do the global ranking in this framework. So after doing the global ranking based on this weight using the rank command, we came to the conclusion that this CY3 is ranked 1, followed by CY1, and then followed by SCP3. So these are the 3 most prominent subcategory or the subcategory indicators for our sustainable business practices. So in this way, we can know among the multiple criteria and multiple decision makers when they are there, that which one is the most prominent for us. And now, since we have identified that these top 3-4 are there, we as an organization will work towards those practices on priority to achieve sustainability in our organization. So that was about this using this multi-criteria decision-making method for a particular case of sustainable manufacturing. Now, if you have anything, you can ask.
Yeah, any question, participant, please? You can raise your hand, then I can unmute you. It was a nice explanation, sir.
Thank you, sir.
Sir, actually, can you please give some light on like how we select the data? Means how to select the expert, and this means which method is better for this collection of data?
Data collection is generally done means by personal interviews with the expert, personal interview or telephonic discussion with the experts only. Experts are selected on the basis of their experience in the relevant field, as I said. So we decided that at least 10 experts, means 10 experts we are selecting, and they should have at least 10 years of experience in their particular field, and they should be working at some middle management or senior management level so that they know about certain things. Yes, few people I think have raised hands.
Yeah. Okay. Unmute. I want to unmute.
Sir, good afternoon.
Good afternoon.
Sir, this is Professor Indira Rani. Sir, can you please tell me, when I have a doubt, if it is any categorical parameter, where numericals are not possible. For such criteria, for such things, do we have any criteria of weight, allotting the weight, sir?
No, I didn't understand. Like numericals are not possible means you are saying 1 to 9 scale is not possible.
Yeah, it is very difficult to categorize within that numericals or sort of thing. When we go for consistency thing, is there any table from which we can directly pick it up?
No, actually, means what happens is that in this sort of methodologies, it is not always necessary that we ask them that you give 1 to 9 rating. Generally, this 1 to 9 scale is SATI scale or Likert scale that we are using. In that sense, it becomes somewhat mandatory sort of thing that we ask them to give rating. Otherwise, each number has its meaning also. Like if we are saying that 1, we are saying 1 means it is equally important. We are saying 3, that means it is moderately important. Between 1 and 2 means 1 and 3 there is value of 2 that might not be specifically specified, means it is also sort of moderately important. So if the expert does not want to signify a particular number, having difficulty in signifying the particular number, they can say equally important and moderately important. So we as a researcher, we know the meaning of that. So then we can convert it in our scale. Alternatively, what people are doing is they are using fuzzy methodologies for that. Like you can say fuzzy best worst method. In fuzzy, we do not give any numbers there. We have a range, like we are representing one fuzzy number, like we are saying very important. So very important might be, if means in fuzzy also there are now which sort of fuzzy numbers we are using. We are using triangular fuzzy or quadrilateral fuzzy. So if we are saying very important, there we ask the expert to rate in that sense only: important, very important, not important. Because those are the situations where there is a vagueness. We do not say with certainty that this is the particular number. So that is a fuzzy situation. So one particular number, when we are saying very high importance, might be having 3 numbers. If we are saying we are using a triangular fuzzy number, so one will be a lower value representing, let's say 5. One will be a higher representing value representing a number 9. One will be a middle value, let's say representing a number 7. So it can be in that particular range, anything. Similarly, then we are saying high influence. So high influence means that again we might have that is up to us which scale we define. High influence might be varying from 3, 5, and 7. 3 the lower, 5 the middle, and 7 the highest. So there you will see there can be an overlap between 2 numbers also. So in that scenario, we can use these fuzzy numbers best. So I hope it is somewhat clear. Any other question?
Any other question, please? I don't think so, sir.
Someone else also has raised the hand earlier.
They can unmute now, sir. I have changed the setting. They can directly unmute themselves. Sir, how does this Delphi method is better than others?
So Delphi method is better than others in the way where we are saying that in normal method, in normal way when we are going to expert, maybe we are conducting a panel discussion sort of thing where all the experts are sitting at one place and they are giving their opinion. And when we are saying that there are few experts, one is at a very high level general manager, one is at middle manager, one at for the lower level, they might get intimidated from each other and they might not give their opinion properly. So they're sort of whatever is decided by a panel, the head of the panel, that becomes the consensus. In Delphi method, the major advantage is it is not necessary that we are asking them to sit together. We might be asking them to sit at their own space and then provide the feedback. Another advantage of Delphi method is that we are saying that it is an iterative method where it is not necessary we just do one round of discussion with the expert. We will keep on doing this multiple round of discussion with experts until we reach a final, means we can get satisfied that now this is the final result. So let's say in the first round, 7 experts had one sort of opinion, 3 had different opinion. Then what we'll do, we'll hide their identities and then give the questionnaire that was filled, early responses along with the comments, again, we will circulate it to the experts for their further consideration. Then after seeing the other comments also, people might come up with some new ideas. Yes, like that, yes, this particular indicator is not suitable. Yes, I was earlier thinking wrong. So they might modify it. And until a final consensus is reached, that sort of iteration will keep on continuing. So that is the major difference here.
Yeah. Thank you, sir. So I think there is no more question. I will just ask last one. Sir, is there any limit for this best worth, like the how many minimum number of parameter we can take or maximum number of parameter?
As we can say, see in our this solver, we have this 3. I mean, starting from 3 up to 9, we can take.
Okay.
That we can take, but it is generally said that for getting optimized result is restrict to maximum 7 criteria under 1 category. So that will give better results. And best result we can get when we have a situation like, let's say, main category had 5 variables, and then under each main category we have 5 variables. Because what happens is, like in our problem, we saw that there are 3 main category variables. Let's say this is the average that we got, although the average was different. Let me go back to the result sheet. So this was the average. So here clearly you can see that there are 3 variables. CY, that circular economy, is having 50% weightage. Now, if we are having more here, like we are seeing the difference 5, 6, and 7. So obviously, with 50% weightage, whatever the subcategory variables that are there, they will be having in the final ranking. Their rank will always be under 1 to 3. So had there been 5 or 6, like here we are varying from 5 to 7. So let's say had there been 5 or 6 main category, then the distribution of the weights will be more even. So there we would have got even better results. But that is the restriction of multi-criteria decision making, that it is not possible to make equal ones here.
Someone asks, sir, what is the possibility of use best worst method for machine parameter optimization? Regarding this, sir, one paper actually I have also seen that in that the researcher, they optimize the welding parameter actually. Means first they identify different welding processes. They prioritize their welding, which welding they are going to use, and then they prioritize the welding parameters. So I don't know, means in other machining parameters, can you please tell whether it is applicable or not?
It can be applied in any scenario where we have multiple parameters and we have to select which one is the best. So any scenario, what means our day-to-day life also, we have multiple parameters, multiple criteria wherever they are there. Be it we are saying machining, under machining there can be multiple parameters for machining, like tool life we are considering, like we are using other operating conditions that are there, number of hours it is going to work, the machine is going to work, and we have to optimize which one is the best. So that can be done wherever we have multiple criteria.
Yes, sir. One person has raised his hand. You can please unmute yourself, Ashwarya Dara. Yeah, you can unmute yourself and you can ask question.
Hello, sir. Good afternoon.
Good afternoon.
Yes, sir. So actually, currently I'm working on this Mcdm technique. So recently I have found that there are many Mcdm technique that daily we have created an arriving new technique. Now to solve or to select any sort of alternative, which one to select? Like daily, if we see recently Waspers, Topses, Fuzzy Topses are arriving. Now, which one to select? How will we pick that this is the right technique to find out the alternative or to rank?
Then again, you have to maybe apply Mcdm technique on these techniques itself, yes.
Yes, sir. But how to find out which one is going to be the suitable
There
one?
are 2-3 things that we consider. One is your understanding about the particular problem, particular technique, because now there are multiple techniques, and eventually, as you said, that more and more techniques are coming up. So first thing is that we understand that technique properly. So all the techniques, they are giving you same sort of result. Like you are saying, best first and topsis. So there is certain difference between these two techniques. Like best first is always used for ranking the criteria. Topsis you will see primarily is used for in combination with best first or AHP for ranking the alternatives. So that is the basic difference. So first we need to understand what is the use, where we are going to apply. Some techniques are very good at certain particular things, like AHP and best first you will see they are good at ranking the criteria only. But when it comes to ranking the alternative, they do not do that much good job. But topsis, Vickers, these techniques are either made, COCOSO, these are made for ranking of alternatives only. Like I have not shown you the second portion because of the lack of time here. So next we did in this case study was rank certain manufacturing organization based on these parameters. So that is, in that case, those manufacturing organizations are alternatives. For that we have used COCOSO here. In other publications I have used Vickers also, we have used topsis also. So multiple techniques are available. So first is application part, that where you want to apply what you want to do. Similarly, techniques like D-metal, ISM, they are not giving us ranking per se, they are giving us some sort of contextual relationship between the alternatives. So that is a third sort of application. Now coming to the understanding, whether you are able to understand the technique or not. When this best first technique was developed initially, many people didn't know how to apply this, because this best first solver was not available. We have to form the whole linear programming problem and then solve it through Excel. So that was very difficult. So that now with the evolving things, if we have understanding, we can select. So it is always better first see what is the application, then under that application see what are the available methodologies, see which one I can understand properly and which one is more advantageous. Like if you compare, so you want to see why I have applied best first here rather than the AHP, then I would say that best first is having the advantage, major advantage over AHP, that it requires lesser number of data points. As we see, only two vectors are required. One is best to others, other is others to us. In AHP, as I show, a full comparison matrix is required. And other is that it is now much more easier to implement this methodology, and results are also more optimized. So that way we can decide which one to select.
Sometimes it becomes difficult, like whether we should give it 3, 4 or 5. But in best worst, I think, as you said, which one is best, which one is worse. It is easy to select.
Once we have selected which one is best, which one is worse, then the comparison becomes very easy.
Yeah, definitely, sir. Yeah, thank you, sir. I think.
Thank you so much, sir.
One more person.
Yeah, 251. I don't know the name. Please unmute yourself.
Sir, I'm PP Revankar from Kerala Tech University. Sir, could you just quickly throw some light on design of experiments as a tool for optimization, and how does it compare with the recent data analytics tools like deep learning and the others, new things what we hear?
So that is the design of experiment is totally different thing. You are talking about deep learning is also totally different thing, and this multi-criteria decision making are totally different thing. So if we compare multi-criteria decision making, as we have been discussing, where we have multiple criteria, and we on the basis of that we have to make a decision that first of all which one is most important for us, and then we can compare the alternatives. In design of experiments, we are primarily seeing like we have set up an experiment, or we have two sort of situations where we are firstly primarily seeing that whether there is a difference in among means of those two settings or not. So which setting is more optimal for us, that is there. And deep learning AI, they have multiple applications. So that depends upon our use or on our understanding.
Yeah, design of thinking, I think this is relevant to Taguchi methodology, like where they select L9 or L19, some experimentation we do.
So design of experiments.
Yes.
The basis is basically ANOVA. We are comparing the means of the different settings that we have made for our experiment, seeing whether there is a difference in mean value or not of the two, that particular setting, and that will help us make decision which one is the most optimal for us.
Sir, may I just add on to that? So now, how the statistics is important, or is statistics important, more important than the physics of the problem? We have got a process where we have got a defined process, like the mechanics of materials says about the two life and all. So how can statistics add, or maybe how it can connect in predicting the behavior of a process?
Statistics can help us in more informed decision making here. So mechanics that we are talking about, or physics that we are talking about, that is helping us that determine, like say you are saying that determining the two life, for that we have certain process or certain formulas, and for that. Now statistics, when we are talking about, means you might use that particular formula to solve in your particular situation. But if we want to say something generalized, we are saying that this one is particularly, this result I have come across, this is statistically significant, or this is significant or not. Then the role of statistics comes with where we have collected data from multiple sources and tested that data using some statistical techniques, and concluded that yes, that is actually statistical significant in various settings that we have collected the data from.
Yeah, I would like to add, sir, like generally we also have this p value. So generally we say that we are confident up to 90% or 95%. So as sir said, it is generally to just to make decisions, how sure you are on your decision. Yeah. Any other question? No, I think we got all the answers. So thank you. It was very interactive sessions, and in coming lectures we will bring some experts relevant to like Six Sigma, lean manufacturing. So there you will have many diverse, you can say, area from where you can pick all these we can say criteria. Those technique will help you to consider different criteria. For example, lean will discuss about waste, and then you can utilize the best worst method that we have explained here. So everything, just be with us with the coming lectures. So we will start from tomorrow morning 10 o'clock, and after that once again at 2 o'clock tomorrow afternoon. So I will try to bring an expert from our relevant field only, so we will discuss more. Thank you everyone, we'll see you tomorrow. Thank you sir, thank you Dr. Gupta.
Thank you Professor Manjit for inviting me, and thanks to the lovely audience for patiently listening to me and for such an interactive session. And I'm available. You can search me on LinkedIn, or I am available, or you can search my details on website also of IIT ISM. If you have any doubt regarding MCDM techniques, you can always drop a message. I'll be available for.
Yeah, sometime in this session we have less time, and we would not able to get the exact question that we want to ask. So sir is saying you can follow him on LinkedIn or his profile. Yeah, thank you.
Okay. Thank you very much everyone.
Yeah, thank you everyone. Let us call it